Question number 32. The graph shows the variation of the gravitational potential V, which distances r from the center of a planet of radius r. The center of the planet, okay. A mass m is placed at r equal to 3r. You are placing a mass m out here, which means what? This is your planet of radius r, and at a distance of with r, okay, a mass m is placed at r equal to 3r. R equal to 3r means starting from here, you need to count. This is your 2r, and you are putting a mass. Okay. Then when what quantity when multiplied by m gives the gravitational potential energy of m due to the planet. Okay. So you need to find out, okay, GPE. Now, when you say GPE, how do you define GPE? That's the question. Yes, put it in a rounded way. So GPE is nothing but m delta v, right? GPE is m delta v. How do you get delta v here? Now let us read what is being given here. Options. Gradient of a straight line and 3r, definitely no. Okay. Gradient will be the ratio of, gradient means what? Slope, right? If I take the slope at any point, if I take a slope here, this will now be a ratio of changes in y-axis, divided by changes in x-axis. This is not the answer. Okay. So definitely it is not delta v by delta r, because it's just m multiplied by delta v. He is asking you what is this quantity to be written there. Then area under the curve between r and 3r, that is also not the right answer. Okay, because you just need delta v. Gravitational potential value of 3r. Now let us look at that gravitational potential value. What is this now? So this is nothing but at this point, gravitational potential value at this point over here. But here it is only v1 here. Okay, it is only v1 or v2, whatever you call here. Now what will happen? What is being asked over here? What is the potential energy? Therefore, so this will be mass multiplied by the potential energy. Okay, with respect to this one, the potential energy inside this would be infinity over here. Okay, at a larger distance, we just take the value of v2 here. Thus m into v2 will give me the gravitational potential energy of the object when it is at this point. Okay. In fact, if you take delta v also, what you need to do is, what is this delta v here? Delta v refers to v at a point minus v at infinity. This is your delta. Okay, I mentioned incorrectly earlier. So delta v is equal to so much. So as a result of this, you will take mv2 minus what is the potential at infinity. I can now draw it like this. It goes to infinity here. So you see, this will now automatically become 0 here. Okay, so therefore it becomes infinity. This will be equal to VR. Okay, so delta v at this point is equal to VR. So therefore mv2 minus 0. This will give you the right answer. So if you find the gravitational potential value of 3r, multiply that by small m, then that will give you the gravitational potential energy at how you need to find out. Okay, remember your delta v is always calculated as v at that point minus v at infinity. It should always calculate delta v like this, and GPE is always calculated as m times delta v. Let us move on to the next one.